Good morning, everyone. Today, we will be having a discussion regarding one of the major topic in general mathematics included in the second quarter. It is in a module 4, simple and general annuities. By the way, this is your teacher 2 from Pantalan Senior High School, Sir Kenneth M. Abri. Start with, let's identify first what are the learning competencies of this module. So at the end of the lesson, the students are expected to: first one is to illustrate simple and general annuities. Second one is to distinguishes between simple and general annuities. But before we move on to the lesson proper, so I have here some rules and regulation to be followed while listening to this video. Things to remember and needs to prepare. First one, prepare the following before you continue this video. First one, yellow paper, scratch and answer sheet. Scratch for your computation and answer sheet for your final answer. Ball pen and scientific calculator. Second rule is to follow the direction in each slides. Third one, listen carefully. And the last one, be honest in answering. So I will give you 3 minutes to get all the necessary things in this video. Okay, I think everything is okay. So let's continue. So let's find out how far you might already know about this topic. Please take this as a challenge. And don't forget to have fun. The title of this activity is What I Know. It is a multiple choice. You need to choose the letter of the best answer. So write the chosen letter on your answer sheet with the title What I Know, and then numbers your paper 1 to 15. Start. Let's have this first question. So what is referred to as a fixed sum of money paid to someone at regular intervals, subject to a fixed compound interest rate? A. Compound interest. B. Simple interest. C. Annuity. Or D. Annuity certain. Question number 2. So what type of annuity is illustrated when the interest conversion or compounding period is equal or the same as the payment interval? A. Annuity certain. B. Annuity uncertain. C. Simple annuity. Or D. General annuity. Question number 3. What type of annuity is illustrated when the interest conversion or compounding period is unequal or not the same as the payment interval? A. Annuity certain. B. Annuity uncertain. C. Simple annuity. Or D. General annuity. Question number 4. What do you call the fixed payment and interest over a specified time? A. Annuity payment. B. Interest payment. C. Due payment. Or D. General payment. Question number 5. Which is an example of annuities? A. Interest. B. Rent. C. Bills. Or D. Savings. Question number 6. What do you call the type of annuity in which the payment are made at the end of each payment interval? A. Annuity certain. B. Contingent annuity. C. Ordinary annuity. Or D. General annuity. Question number 7. What do you call the type of annuity in which payments begin and end at a definite times? A. Contingent annuity. B. Ordinary annuity. C. Simple annuity. Or D. Annuity certain. Question number 8. What do you call the type of annuity in which the payments extend over an indefinite length of time? A. Contingent annuity. B. Annuity certain. C. General annuity. Or D. Ordinary annuity. Question number 9. A payment made at the end of each month for money borrowed that charges 1.05% interest compounded quarterly. What type of annuities is being represented? A. Simple. B. General. C. Ordinary. Or D. Annuity due. Question number 10. What type of annuity is represented by a deposit of 6,000 pesos that is made at the end of every 3 months to an account that earns 5.6% interest compounded quarterly? A. Simple. B. General. C. Ordinary. Or D. Annuity due. Question number 11. Which of the following situations is an example of simple annuity? A. 2,000 pesos deposited every 6 months for 2 years at 8% per year compounded monthly. B. 2,000 pesos deposited every month for 2 years at 8% per year compounded annually. C. 2,000 pesos deposited every month for 2 years at 8% per year compounded monthly. Or D. 2,000 pesos deposited every quarter for 2 years at 8% per year compounded monthly. Question number 11. Question number 12. Which of the following situations is an example of a general annuity? A. 5,000 pesos deposited every month for 5 years at 8% per year compounded annually. B. 5,000 pesos deposited every 6 months for 5 years at 8% per year compounded semi-annually. C. 5,000 pesos deposited every 3 months for 5 years at 8% per year compounded quarterly. Or D. 5,000 pesos deposited every year for 5 years at 8% per year compounded annually. Okay, this illustration is for questions number 13 to 15. So I will give you 1 minute to take a look at the cash flow of an annuity. Remember that questions number 13 to 15 is related to that cash flow. Okay, so moving on. So let's have this question number 13. What is the rate of the interest? A, 1.05%, B, 5%, C, 0.05%, or D, 0.5%. Question number 14. What is the term of the payment? A, 5 years, B, 4 years, C, 6 years, or D, 1,000 years. Question number 15. What is the sum of all the payments of the given annuity? A, 5,000, B, 5,445 pesos and 82 centavos, C, 5,225 pesos and 36 centavos, or D, 5,525 pesos and 63 centavos. Okay, that's all questions in our What I Know portion. So let's check whether your answer is correctly. Remember one of our rule, so be honest. So kindly check your work with this key to correction and count the number of the correct answer afterwards. For the key to correction, with number 1, we have letter C. Number 2, letter C also. Number 3, letter D. Number 4, letter A. 5, B. Number 6, C. 7, D. 8, A. 9, B. 10, A. 11, C. 12, A. 13, B. 14, A. And number 15, D. Okay, so kindly count the number of the correct answer and write the number of the correct answer at the top portion of your answer sheet. Okay, so moving on with the lesson proper, which is talks about the simple and general annuities. So let's have first their definition. When we say simple annuity, the payment interval is also the same as the interest period. While in general annuity, it refers to an annuity where the length of the payment interval is not the same as the length of the interest compounding period. Okay, so that would be their difference. Remember me, before we go on with the lesson proper, as the saying goes, a person who does not remember where he came from will never reach his destination. So this saying is very popular, passing from one generation to another generation. For you to remember the previous lesson, here are some exercises to refresh your mind. Sample problem: if 40,000 pesos is invested for 6 years at 5% compounded quarterly. The question is, give the value of the following using the formula A is equal to P times the sum of 1 plus I raised to N, where A is our compound amount, P is the principal amount, I is the periodic rate, wherein we can get that periodic rate by simply dividing the rate over the compounding period. And N is the number of compounding period, wherein we can get the value of n by simply multiplying t and k. T is time in terms of years, and k is the compounding period. So from the given problem, here is our given. So A is unknown, or the compound amount is unknown. The principal amount is 40,000 pesos, or P. Our periodic rate is R over K, or 0.05 over 4 is equal to 0.0125. Where do we get that 0.05? Since from the given problem, if 40,000 pesos is invested for 6 years at 5% compounded quarterly, the rate from the given problem is 5%. So you need to convert that into its corresponding decimal form, which is equivalent to 0.05. And where do we get the value of 4, or the compounding period? So the compounding period from the given problem is, is talk about quarterly. So the value of that quarterly in the compounding periods would be 4. So that's why we can get that 0.05 over 4, which is equal to 0.0125. And lastly, the n, or the number of the compounding period, by simply multiplying the time in terms of years and the compounding period. So that's why we have 6 times 4, which is equivalent to 24. Next, for the solution, so we need to substitute the given from the given formula, which is A is equal to P times 1 plus I raised to N. So we get A is equal to 40,000 pesos times 1 plus 0.0125 raised to 24th power. So A is equal to 40,000 times 1.0125 raised to 24th power. And then by simply doing the operation, so our compound amount is equivalent to 53,894 pesos and 4 centavos. Solve for the compound interest, here is the formula. Compound interest is equal to the compound amount minus the principal amount. From the previous problem, the compound amount that we get is 53,000 pesos, 890, rather, 53,894 pesos and 4 centavos. And then the principal amount from the given problem is 40,000 pesos. So we need to get their difference for us to solve for the compound interest. And then after computing, we get 13,894 pesos and 4 centavos as the value of our compound interest. Okay, here are some of the important terminologies or information in this topic. We have first the annuity payment. Annuity payment is the payment of each period, is fixed, and the compound interest is fixed over a specified time. When we say annuities, these are accounts associated with streams of annuity payment. And when we say annuity, it is a sequence of payments made at equal or fixed intervals or periods of time. Here are some of the examples of annuities. First one, we have that rental payment, monthly pensions, monthly payment for car loan, and educational plan. Here are the classifications of annuities according to its period. According to payment interval in interest period, according to time of payment, and according to duration. Let's start first with according to the payment interval and interest period. When we say simple annuity, an annuity where the payment intervals is same as the interest period. While in general annuity, an annuity where the payment intervals is not the same as the interest period. According to time of payment, when we say ordinary annuity, it is also called annuity immediate, a type of annuity in which the payments are made at the end of each payment interval. But when we say contingent annuity, it is an annuity in which the payment extend over an indefinite or indeterminate length of time. According to duration, when we say annuity certain, an annuity in which payments begin and end at definite times. But in contingent annuity, an annuity in which the payment extend over an indefinite or indeterminate length of time also. Another terminologies, when we say ordinary annuity, the payment is made at the end of each period. Periodic payment, each payment in an annuity. When we say payment interval, the time between the successive payments dates of an annuity. And term of the annuity or T, the time between the first payment interval and last payment interval. Future value or the amount of the annuity. The sum of the future values of all the payments to be made during the entire term of the annuity. When we say present value of an annuity, the sum of the present values of all the payments to be made during the entire term of the annuity. Simple annuity, the payment interval is also the same as interest period. So here is an example. 50,000 pesos deposited every year for 5 years at 8% per year compounded annually. So notice that 50,000 pesos deposited every year for 5 years at 8% per year compounded annually. Since the compounding period is similar to the payment interval, this is a type of simple annuity. The cash flow of the given situation can be illustrated in the time diagram below, wherein our cash flow, we have two important values, which are the payments and then period per year. The upper part would be the payment, and then the lower part would be the period per year. The future value of all the payments at the end of the term, wherein T is equal to 5. Okay, so from the given cash flow, on the 5th year, we have that 50,000 pesos. Okay, 4th year, so we have 50,000 pesos times 1.08 raised to 1. So where do we get that 1.08? Okay, 1.08 comes from 1 times I. Okay, where N is equal to 1. Okay, the 3rd year, we have 50,000 pesos multiplied by 1.08 raised to the 2nd power, and so on and so forth, up to the 4th power. Okay. Since the question from the given problem is the future value of all the payments at the end of term, which is T is equal to 5. So we need to add all the future values obtained from the previous step by simply doing the operation. Since on the 5th year, we have 50,000 pesos, which is equivalent also with 50,000 pesos. Yung 50,000 pesos multiplied by 1.08 raised to the 1st power, after computation, we get 54,000 pesos. The third one, 50,000 pesos multiplied by 1.08 raised to the 2nd power. So we get 58,320 pesos. Next one, so 50,000 pesos times 1.08 raised to the third power. After computation, we get 62,985 pesos and 60 centavos. And lastly, 50,000 pesos multiplied by 1.08 raised to the fourth power, we get 68,024 pesos and 45 centavos. Okay. So in the value are the values after computation. So we need to round off numbers to the nearest hundreds. Okay. So since we need to add all the future values obtained from the previous steps, the total is 293,330 pesos and 5 centavos. Therefore, that 293 pesos 293,330 pesos and 5 centavos would be the future values of the given simple annuity. Next, general annuity. When we say general annuity, it refers to an annuity where the length of the payment interval is not the same as the length of the interest compounding period. So the examples of general annuity would be this one. First, monthly installment of a car, lot, or house with an interest rate that is compounded annually. And paying a debt semi-annually when the interest is compounded monthly. So that would be an example of general annuity. Let's have an example of general annuity. Find the amount of the annuity of 700 pesos every 6 months, half year, for 12 years if interest is 6% compounded monthly. So here, the payment interval is half year or 6 months. Is different than the interest period or annual. This is general annuity. We must match the interest period to the payment interval. We must find the semi-annual rate that is equivalent to 6% compounded monthly. Our first step is using the formula A is equal to P times 1 plus I raised to N. So we need to find the value of 1 peso invested at 6 years compounded monthly after 1 year. Okay? So we have A is equal to P times 1 plus I raised to N. After substitution, so we have A is equal to 1 times 1 plus 0.005 raised to 12, or our compound amount is equivalent to 1.061677812. So note that for us to get the value of I, we need to find the quotient of the rate and then the compounding period, which is 6% divided by 12, which is equivalent to 0.005. And for us to get the number of the compounding period, so we need to multiply the term or years by the compounding period. And then we have 1 times 12, which is equivalent to 12. Second step, let the equivalent 1/2 year rate be T%. So we need to note that the equivalent yearly rate would be 2T%. Now, find the value of 1 peso invested at T% per half year after 1 year, given this formula, that A is equal to 1 times 1 plus I raised to the second power. So note that N is equal to 2. The number of times interest is compounded. Kasi we talks about half year. And for us to have 1 year, so meron tayong dalawang half year. That's why N is equivalent to 2. Third step, we need to find the value of I, or the periodic rate, by simply using the formula A is equal to 1 times 1 plus I raised to the second power. The compound amount we get from the previous step would be 1.061677812, which is equal to 1 plus I raised to the second power. Okay. For us to solve for I, we need to remove the exponent by simply squaring both sides. Square natin si 1.061677812 and 1 plus I raised to the second power. Kaya nakuha natin si square root of 1.061677812 equals 1 plus I. And then afterwards, we need to apply the properties of equality. In this situation, so we need to apply SPE or subtraction property of equality. Okay, that's why we have 1.030377509 minus 1 is equal to I. And for us to get the value of I, we need to find the difference of 1.030377509 and 1. And the answer is 0.0303777509. So therefore, the equivalent half-year rate is 0.030377509 or 3.30377509%. So that would be our periodic rate. And then after identifying the periodic rate, so now we can illustrate the cash flow. Okay, the payment of 700 pesos in 24 years. 24 months rather. Okay, the future value of the payments at the end of term T is equal to 24. So we have payments of 700 pesos and the year period natin from 1 to 24. Okay, on the 24th, so we have 700. Okay. Okay. So, in-identify na natin dito sa ating cash flow yung shortcut methods on how do we identify the cash flow. Okay. The first three and then the last interval. Okay. For us to get the future values obtained from the previous step, we need to solve or find the sum of all the values obtained from the previous step. Okay, and then afterwards, after adding, we get the future values is equivalent to 24,212 pesos and 83 centavos. So you can check whether this solution is correct by simply using your calculators and by inputting all the necessary equivalents into your calculators. Okay, so I think we are done through all the important terminologies and examples. All of you can be able to illustrate and distinguish simple and general annuity. To test whether you understand the lesson today, you can now answer the separated activities I sent to you on our group chat. The file name of the activity sheet is General Mathematics Week 6. Write down your answer on your yellow paper and include your answer sheets on the next retrieval of modules in your barangay. Feel free to ask questions via Messenger. So good luck and God bless everyone.